Hello. Welcome to this tutorial on creating pumps in MakeFlux Pro 3D. We have the ability to save generators, pumps, and fans to our library for quick access when needed. Here in our library we see that we have a few pumps that are registered. Here, for example, in the dossier of this type of pump, we have a series of pumps that are directly integrable into networks. We can immediately check their operating points, depending on the network. It is therefore necessary to know how to save and add a pump to our library. This is done simply using the performance curve of our pump. This performance curve here for a series of several pumps, derived from a pump, for example of diameter 124 mm, which is trimmed down to diameter 102 mm. We will see how to insert and create a new family of pumps, if necessary. In this performance curve, we see the evolution of the pressure HM in meters of column of fluid, according to the flow in cubic meters hour. And we also see the evolution of NPSH and efficiency in the same flow range. So this pump is a pump for about 1 cubic meter per hour. We will see how to save it in our library. In the Library tab we have Pump Editor. We click on the Pump Editor icon, and the pump editing and registration interface is displayed. We'll start by naming this pump. We'll call it Multi-V Pump 1 cubic meter hour. We can select its nominal diameter and say that it is a DN21. We are going to see how to enter the characteristics of this pump, of this generator. It could be a fan or a pump for liquid. It's the same approach. The only difference with a fan is that instead of selecting fluid column meters, we will select delta P Pascal. And for a fan, NPSH curve, because there is no cavitation problem on the fans, designed for air. So we are going to see the most complex case, therefore of a pump for liquid, for which the NPSH curve must be provided. We enter the points of the curve, which gives us the graph. Here we enter 6 curve points. In our graph we read that the flow goes from 0 to 3 cubic meters hours. We will stop at the maximum operating point, because after the yield falls, it is not worth re-entering the area with bad yield. But we could push up to 3.5 cubic meters per hour. We're going to stop at 3 cubic meters an hour. We enter the maximum value of 3 cubic meters per hour. And we will enter intermediate values noted on the graph. And 1 cubic meter hours. So we entered the flow range. We are now going to enter the load heights. We have selected the 124 mm diameter pump. So we will name it Multi-Pump V 1 cubic meter hour 124 mm. OK, we enter the points. So at 0 cubic meter hour we have a load height of 240. We see the graph updating based on the data entered. We enter the following points. When we entered our load heights, the graph updated in blue. The blue columns are the input data, and in red is the pump curve. So the values may be slightly different, because when you make an entry, it's often a reading on the chart, and the data may be erratic. So there is a polynomial function, which smooths the curve consistently. So we have in red, the pump curve, which is a polynomial calculated based on the points entered in the fields here. On the documentation given by the manufacturer, we also have the NPSH curve and the efficiency curve. We enter the points of the yield curve. So here is the yield curve. So we entered the characteristics by entering points on the curve. If we have a photo, we can apply it. We can indicate the manufacturer's website and information that we believe is important. We could have created a coupled generator. If, for example, we want to put two pumps, either in parallel or in series, we have an equivalent pump creation system to create a new pump that we could save in the library, which would correspond to a coupling of several pumps in series or in parallel. We save our generator, and we see that the pump has been saved in our library. Here we verify that our multi-pump V1 has been registered. We are going to create a folder for this family of pumps. Create a subfolder, we will call it Multi-V Family. OK. So in our pumps, we have a subfolder, Multi-V Family. We drag and drop this first newly created pump. And we are going to decline this pump in pump family. So we edit the pump. We set its inlet diameter. We select a DN25 and its outlet diameter DN25. And we save the pump in the library. We are going to enter this pump in its folder, Multi-V. We are editing the pump. And we are going to edit, create a pump, therefore derived from this pump there. We take our performance graph again. And we will say that this pump is no longer the 124. But the 123, for example. The NPSH and yield characteristics remain the same. We only have the 6 load height values to enter. Here, we have entered the new performances for this pump, trimmed by 123 mm. And we save the generator, so 123 mm. And we drag and drop it into his folder. And we start again on the next pump. We pass in our performance data, and we create the trimmed pump at 121 mm. Quite simply. On entering the pressure height values, we therefore enter 208 for 0 cubic meter hour, etc. We are thus going to create our family of pumps and save it. Here, we have created our series of pumps. We are going to test it right away. We are going to open a network. Here is a network that already has a pump. We're going to remove the pump that's there. You can select an item, and press the delete key to remove an item. Here, we want to insert a pump that we have just created. We are going to edit the pump. The inlet and outlet diameter of this pump was 30.5 in diameter. The network on which we want to connect it starts with a diameter of 100 mm. Then two choices are offered to us. Either we have the possibility in our supplier catalog to have a pump which has the diameter of our network. So in this case, we will modify the diameter of our pump to 100 mm. And use it directly on this network at 100 mm. Otherwise, you will have to change the diameter. So here we are going to take the opportunity to show a little trick. When we have created a complete network, and which begins for example here at diameter 100, and we would like to create another part upstream of another diameter, we are going to start a new network as we would like it to be. So we're going to create a new upstream network, and we want this network to start with a diameter of 30.5 mm. We go to our library, in our pipes, choose an element, or create it if it doesn't exist. Here it already exists. We drag and drop our conduit, and we size it to the right length. And we're going to put a widening on it to go to 100 mm. This will allow the connection of our pump to our network. Enlarge, create a cone. We will put it at 100 mm. Insert the cone downstream, and here is our cone. We just have to insert our 100 mm network downstream of the connection system. We use the function insert downstream network. We select the 100 mm network, which is placed on our connection. So we remove the pump which is at the entrance, and the orientator which are no longer used for anything. Our network has therefore been modified as input. We can slide our pump there, multi-V with a diameter of 30.5 mm. If we have not selected an element or insert the pump, the software offers to place it automatically at the beginning of the network. Here is our multi-V pump which is inserted upstream. We are going to test this system. We launch the search for the operating point with this pump. We get the flow and all the results that may interest us. So we click on the objects as usual to get the detailed parameters. We can read here in the properties of the different elements, and we can have the calculation of the pressures, colored for example, or a simulation of the particle path test. So here we have a network with a small loop and valves with different degrees of opening. So there is more flow in one pipe than in the other. Because this valve is more closed, it is 75% closed. This one is 25% closed. So much for this tutorial, showing the creation of pumps with Mechaflux Prod.